Yeah, there we go. All right. So today we're talking about Redux. Has anyone here used Redux at all? Who's heard of Redux? Let's start there. And who's used it? Got like 2. And who's liked it that's used it? Same. Okay. Who has a basic understanding of what it is? All right. Cool. So Redux is a predictable state container. And we'll elaborate on what that is here in just a minute. But if you go to their docs, that's what they introduce themselves as, is a predictable state container. And Redux runs everywhere that JavaScript does. You'll see it client side, you'll see it server side, and if you're building things with like React Native or any native environment that supports JavaScript, it works there as well. It's not attached to any specific environment. So it is view library agnostic. It will work with anything. It's most often found with React, but you can work with it in Angular or vanilla JavaScript or handlebars or really anything you want. It doesn't really care so much about what it's connected to. Okay. And as you may know, we're looking at adding a React Redux starter stack to what we currently support, and that's currently going through our approval process. So hopefully there'll be an announcement for that sometime soon. This year. This year. Sometime this year.
Isn't that what we said last year?
That's what we said last year. So Redux has like amazing docs and video, so much so that this was a pretty easy thing to write because I just copied and pasted a lot of it. I mean, they've overdone their documentation. The creator of Redux has a very extensive egghead IO series on using Redux. If this interests you at all, I would take a look at that. It's very, very well documented. And just point out, it really packs a punch for what it does. It's only about 2K, but it's really, really powerful. And we'll get into that, its power just here in a second. But it's a pretty amazing, almost micro library for where it fits into your application and what it does. So let's look at the word predictable state container. We'll kind of break that down a little bit. We'll start with state, right? Because state is ambiguous. It's an overloaded term. It means so many different things, okay? So Redux isn't a database. It's not meant for long-term persistence of things, right? So that kind of stuff you wouldn't manage in Redux. So when we talk about session state, it doesn't manage your cookies. It's not that kind of state, right? So how about the internal state of a component? For instance, like your hover state or your click state on an HTML element. Nope, doesn't concern with that either. So what then? So this is dealing with your application state. Typically what you're going to see is in-memory data assignment, like anytime you use var, let, const, anything like that. But that data needs to have some application significance. We're not talking like when you assign var I equal to 0 in a for loop. It's more of the things that are relevant to your application. Typically this state, it's referenced asynchronously, meaning you will maybe set it here, continue processing. At some time later, you're going to come back and you want to look at that information again, maybe change it. So it may change asynchronously as well. So can everyone see that? So for instance, this would be like a simple state, keeping the state of something, a scorecard, for instance, and maybe we're building a scorecard app, and we need a memory reference for what the current scores are.
Thanks for the 1 point.
You're welcome. Matt, good luck next time.
Good job winning that, Bruce.
Hey, I won that.
No, it's hard.
All right, so let's take an example of just this little select box or this drop down over here on the left, right? And determine which parts of that would be considered application state, which parts aren't, just to kind of make sure we have clarity on what state we're talking about, okay? So the fact that the drop down is open, this is not app state. This is internal component state, right? Same with that we're hovering over something right now. You wouldn't manage this kind of state in Redux. However, the list of options that are in your select box, that would be something you'd find in Redux. And then when your user clicks on one of them, that's going to have some sort of significance to your app. The chosen option would be that kind of state. So does the distinction make sense to everybody? Good? Okay. So your application state, it can consist of transform server responses. So you make an asynchronous call, you get some information back, you maybe need to kind of tweak it a little bit for your app, and then you want to keep it locally. So cache data, essentially. That could be a big part of that. In addition to that, anything created locally by your end user, typing in forms, how they've used your app, where they've gone, history, that kind of stuff.
You mentioned a couple things with user interacting with the UI. It's not, in my opinion, it's not application state until it's been vetted, validated, it's ready to go into the application.
Correct.
State,
yeah.
right?
So this is significant to the app. That goes back to it. This is data that is significant to your application. So it's just not everything. You need to determine up front what's significant for you to retain, and that's the state you keep. That's the state we're talking about. So it also can include some more of the complex UI state, right? So for instance, if you're doing client-side routing, potentially you can keep that in this state. If you have a tabbed interface and you want to not only define what the tabs are, which one of the tabs is active, that would also be done within this type of state. Whether to show a spinner, to show pagination, any like alert messages or notifications that you want to display to the end user. This is all the kind of state we're talking about. So I think I beat that to death. All right. So let's talk about the term predictable when we talk about the predictable state container. Okay. So this comes straight off of their Redux's documentation. It says if a model can update another model, then a view can update a model, which updates another model, and this in turn might cause another view to update. At some point, you no longer understand what happens in your app as you have lost control over the when, the why, and the how of its state. Who's experienced this? Everyone else is a liar. All right. So when your system is opaque and non-deterministic, it's hard to reproduce bugs and add new features, right? Because what it boils down to, you really don't understand what's going on. So let's look at those. Opaque. Anyone want to describe what opaque means in that context? Anyone?
Black box.
Black box. Thank you. Basically, it's stuff is happening and you can't even, right? Like you don't know what's going on. You don't understand. How about non-deterministic? What does that mean?
It means the path can change through different iterations of the same operation.
Correct. So we talked a couple times ago about pure functions. And a pure function is deterministic because given the same set of inputs, the output will always be the same, right? And the opposite of that would be it changes every time. So the same set of actions produce different results. And if you're trying to track bugs, that's really hard to figure out what's going on because sometimes it does this and sometimes it does that, right? And it's kind of funny, like it correlates to the definition of insanity a little bit, right? So literally when you make impure functions, you're encouraging insanity. Just pointing that out. Literally. All right. So what happens on top of all this complexity, now we're going to add asynchronous behavior. Right? Things like your state can change over time based on this and that. We don't really know what, right? And not in a good way, right? You can't keep up anymore. You can't understand. It's hard to figure out what's going on. So let's talk about how Redux is different in this context. So same thing. The same input produces the same output, always, right? So no surprises there. In addition to that, any potential state change is clearly declared beforehand. So there's no magic, there's no black box, everything. If you want your state to be retained in your app, you've declared how. When that changes, you declared how. So there's no magic there, right? And then the last part of that term is container. So let's look the idea of a container, right? So we've kind of demonstrated some of the complexities of state management when we talk about things changing over time, we talk about mutability, we talk about all this stuff. So obviously, the smart thing to do is just scatter your state all over the place, right? No. So in an uncontained app state, this is when the state of your application is decentralized and it's spread across your entire application. It's often hidden with behaviors and functions and closures and or a bunch of global objects. And as your app scales, this becomes impossible to manage, right? Does that make sense to everyone? So in Redux, your whole app state is stored separately. It's contained in a single object tree inside of a single store, okay? So it helps your mental model a little bit, helps you know where to find things. And there's one way in. There's only one way to get information in, and there's only one way to get information out. So it's very much contained. It's very easy to reason about. It's very easy to control, which makes it predictable. There's clarity and manageability and sanity, right? Okay. So Redux says they're built off 3 principles. This is from their website. We've touched on all of them a little bit already. So one is the idea of the single source of truth. You want to know where your application state, what it is. There's one place to go. You want to figure out what your state is at a given time, the entire state of your app, you can get to it. It's all right there. State is read-only. We don't have all these things all over the place mutating the contents of your state, right? It's read-only. The only way to mutate is to emit an action, which is an object describing what happened, okay? And then you take those objects that have been emitted in, and they're passed through pure functions that accept a current state, the action, and what they do is they produce a new state. So that's the purity there. This makes it very easy to test because there's no mocking. I mean, you're passing in something and you're getting something back, and you do that with the same information, you get the same thing back, right? So it's very predictable. It's very easy to manage, very easy to maintain, and it's very, very scalable as well. So on top of this, Redux has a super simple API, right? So let's look at what that would look like. Does everyone read this? Are we okay on the size? Because it looks pretty small on my screen. All right, here we're importing create store from Redux. After you've done that, you'd import a reducer. We'll talk about what that is in a minute. And as you're authoring an app, this is what you spend the bulk of your time authoring, are these reducers, okay? You import your reducer. You create your store using your reducer. And then from here on out, you can do store.getState. That's going to tell you the state of the store. On top of that, you can subscribe. So you can be notified when any of the state changes. So store.subscribe, and then that's just a notification that it gets called. And it doesn't give you this entire state. It just lets you know, hey, I changed. You can determine what to do about that. In this case, we're just going to get the state, and we're going to log it out. Right? And then you want to make a change, you store.dispatch. You pass in this object type. This is action being passed in. It's just a plain old JavaScript object that has a type. And we're assuming the reducer acknowledges this type. And based on that, it performs some calculation and returns a new state. So that's pretty much the gist of Redux right there. Okay? So reducers is the one I've kind of glanced over. This is, again, where you're going to spend most of your time authoring. So a reducer is just a regular JavaScript function. It's got to be a pure function, right? This is that gives you the transparency and the predictability and the deterministic behavior. And this function, what it does is it accepts a previous state and an action. And based on that, it returns a new state, okay? And if it didn't understand the action coming in, it just returns the state that was passed in. So it just ends up being like a pass-through. If you admit in an action it doesn't understand, the state's just going to be like, I don't know what you're talking about. Just here's the state. Just pass it on through. Right? And here's the signature of a reducer. Previous state, action, new state. Questions, comments? Does this make sense? We good? So we're going to go deeper. Okay.
Can you write your own reducer, then?
You write your own reducers, yep. So here's some rules. This is going along those 3 principles. So these are things you shouldn't do, because if you do these, you're violating these principles, right? You should never mutate the arguments coming in, right? You return a new state. You don't modify the state that came in. You return a new state, right? It should have a new memory reference if it's an object or, well, a new memory reference, okay? You shouldn't perform any side effects inside of that. That means you're not making any API calls, right? Your reducers, they're synchronous code. Okay, you don't mess with the outside environment. You just deal with the data coming in. You calculate, you produce data coming out, right? You don't perform anything that modifies anything else. And inside there, you don't call non-pure functions. So functions that, when you call them, produce different results every time. This ruins that deterministic behavior, right? So you wouldn't in there call in date.now or math.random because that's going to give you different values every time you call it. And basically, to sum up, giving the same arguments, it should calculate the next state and return it. No surprises, no side effects, no API calls, no mutations. It's just a calculation. That's all that your reducer should be. It's just a calculation. Make sense? So here is an example reducer, right? We can look at the signature. You can see it takes in a state. It takes in an action object with a type. We switch over the type, right? And we say, hey, if this is a type of increment, we're going to return the state plus 1. And if it's of type decrement, we're going to return state minus 1. Otherwise, I don't know what you're talking about. Just return the state that came in, right? So did we here mutate any arguments? Yes, no, awake, sleep? No. Perform any side effects? Did we call any non-pure functions? Did we return a new state? Okay, that's it. I mean, that's the gist of a reducer right there.
Aren't switch statements considered dirty?
Some people, yeah. Some people, that's like the smell to people because for a couple of reasons. The question was, doesn't the switch statement feel dirty sometimes? And a lot of it is because it kind of, in some contexts, it violates the open-close principle of being able to extend things without having to modify source code. But you'll see that the way that this scales, the way you extend this is handled in other ways. So you'll just have to trust me on that one for now.
And also, there are other ways to do that.
Yeah, you don't have to use a switch statement. It's just literally what you're doing is you're switching over a type and reacting to it. So if you want to reinvent switch, go for it.
Also, the main smells of switches you actually avoid.
Right. So let's visualize how Redux works for a minute. I just made this like 5 minutes before we started, so hopefully it works. Okay, so Redux manages internal state, has its own internal state tree, right? And we've created the store, has that tree, and we've already defined a reducer here, right? Here's our reducer signature. It's got a state in action that returns a new state, okay? We dispatch a type. A type comes in. We say, okay, what Redux does is, oh, when a thing came in, I'm going to grab my internal state tree. I'm going to grab that action type that just came in. I'm going to pass those two things to the reducer, and that will produce a new state. Make sense? Pretty simple mental model, maybe, yes, no? Good? Okay. All right, live coding. So let's put this to the test a little bit, okay? Can you guys see okay? Bigger, smaller, good?
Bigger.
Good?
Bigger.
More? Okay. So here we're gonna show how this works a little bit, okay? So on this, I'm on a JS bin, okay? So some of the things I've already prepared with this bin is I've already added Redux to the script tag. I've already enabled ES6 or Babel so I can use newer features and things like that. And I've already faked an import statement since we're dealing with global things here because of JS bin. Instead of an import create store, we're actually just gonna destructure that global variable in a similar way, right? So that's what I've done here, create store, okay? So our task number 1 is to create a reducer called myReducer that starts with a default state of 0. It accepts 2 action types, increment and decrement, right? And from there, we should be able to determine what those do, right? It's pretty self-explanatory. And you're welcome, if you go to the slides, for those who want to follow along, have Slack open. I remember him. Let's see. All right. So in the front end channel on Slack, if you wanted to mess around as we go for it. It's there. Okay. So we need to create a reducer. A reducer, again, is just a function that accepts a state. In this case, we want the default state to be 0. And an action object, which we're just going to do structure because it's a simple one, right? And based on that, it should produce a new state. So we're going to switch over. We're going to switch over type, and you can choose whatever methodology you want to switch over something. And we're going to say, hey, in case it is increment, we're going to return state +1 because we don't want to mutate, right? In case decrement, we're going to return state -1. And then what else do we need to do? Return state. Okay, that's it. That's the reducer, okay? So task 2, we need to create the store using that, right? So we're going to const store equals to create store my reducer. Okay? So task 3, we want to subscribe to the store, and then on change, we want to just log out the current state. So it's store.subscribe, takes a function. We're going to console.log store.get state. Yeah, it's probably important. Okay. Makes sense so far? Good? All right. And then it says we want to open up this and start dispatching. So let's make sure store is defined. We may need to actually, sometimes JSPen doesn't cooperate. All right. So let's do a store.getState to start off with. Let's just see what happens. So our current state is 0, right? And then we want to type increment. And we've already subscribed, right? So once the state changes, we should get something logged out. You can see we got 1 automatically. It's kind of going up. And down. And then if we were to type something else, nothing happened, right?
So that's interesting in that the subscription's still fired, but nothing changed.
Yep.
How come when you type something else, doesn't you have a default on your switch?
Yeah. My default was what the current state coming in is. Right? So we set when we first created the reducer, we were saying, hey, we want you to pass in a state. If you don't pass in one, we're going to make the default one 0. So we're kind of like setting the default thing coming to be 0. So the very first time that gets called, it's going to be called with nothing coming in, defaulting to 0, and then incrementing up. And as we increment up, each time we get called back through, it's the new state is going to be passed through.
So how come the state wasn't passed in? I mean, what's passing in the state?
So that's that visualization. So action comes in. Redux takes the current state tree, takes that action, it combines them both and passes it into our reducer.
Right.
So Redux is taking what it has registered in its state tree to pass that through. And so in the last time when I passed in this invalid object down here, it's passing in 4 and this invalid action, and the reducer is seeing those, doesn't recognize the action type, and then spitting out what basically came in, which was 4.
Can you scroll up your left, please?
You could just close the header, close that big blue.
This nice, pretty thing?
Sorry, my question is how many, can you only do one reducer?
No, we'll get to that in a minute. It's a good question, though.
Shouldn't we log the default state maybe not doing what we're expecting.
It's not doing what we're expecting.
Well, I mean, deterministic, but if you were hoping for state to change and it didn't.
Did you dispatch, because you dispatched a bad action? Yeah, so if you wanted to, there is ways to introduce logging and things like that if you wanted to do such a thing, right?
I think when you have multiple reducers, you'll see why you just pass it off.
You'll see why, yeah. When there's more than one reducer, you're going to see why. Okay.
I can save it for that part of it, but when you have multiple reducers that operate on the same action,
You can.
that doesn't.
You typically, your actions, and we'll get that in a minute as well, your actions are typically supposed to be unique unless you want two things to react to the same action differently. Like you can manage different things based on that. Does that make sense?
So you're printing out 4 whenever the state changes. You bring out the current state.
Whenever there's I've been notified that the store has changed.
So why with an invalid action does it still print it out?
Because it's in its registries, it thinks it's changed.
So it's not actually that it's changed, it's that, hey, an action came in that could have changed this. And so I'm letting you know,
Yep.
an event occurred, you should check for a new
Right.
state.
So this is a small piece of a big puzzle. In the giant puzzle, these optimizations are taken care of, I promise. So. Any other questions before we move on? Okay. So here's the short version of what we just created, right? So let's look at those actions and then a new concept called action creators, okay? So we know what an action is. We saw it. It's just an object, a plain old JavaScript object, right? It's just these payloads of information that are sent from your application to your store, right? And they're just plain old JavaScript objects. They should have a unique type property unless you know what you're doing. Your type property should be unique, okay? And they can be, depending on what the action is, accompanied by a minimal amount of data. It should be the minimal amount of data required to make the calculation that you need to make to produce the new state, okay? So again, here is an idea of an action called add, right? And in this particular case, it dispatches both the type and the number it needs to add, right? So then we have this idea of action creators, and what they are, they're functions that create these actions, okay? So the actions are the objects, functions create the objects, okay? And what they do is they abstract away the store details from the app that's consuming them. And here would be the same example of, this is an action creator that produces the action object needed for a particular reducer, we assume, right? And it's just a function that accepts a number, and it returns back, it creates the object the store would need, which is the right type, and the format of that number. And so the difference is you would just dispatch it like this. So kind of if you think about the API being exposed to your app is much simpler, right? It doesn't have to worry about types. It just knows, hey, I call this with a number. Mm-hmm.
So when we talked about reducers, we said these are pure functions. Don't call an API. Don't call an impure function like date.now or something. So, but I could potentially do that here, as in I want to create an action to create this action. I need to get an API response before
Correct.
I dispatch it.
Yeah, you're skipping way ahead, but yes. So reducers are synchronous. They're simple. They're supposed to be declarative, easy to read, very transparent, right? No asynchronous. I mean, if you think about some asynchronous things you have to do, I mean, that could look very, very nested and hard to read, and we don't put that in our state container. We want our state container to be clear, easy to read, easy to manage, pure, easy to test, all that. So when we start introducing asynchronous behavior, complex operations, a sequence of things, you're going to start doing those. There's some demonstrations later on, but those come in your action creators, right? Or middleware. So the gist is you don't really ever write actions in your app. You don't write them. You write action creators typically. So, all right, who does this on long road trip with their kids, right? Where you're trying to keep them from going insane, and you say, "Oh, my dad used this too, it drive me insane." But start 0, and then he'd wait like 5 seconds, add 10, divide 2, multiply 5, right? He's basically using all the kids as a little state machine, and we're supposed to like, and I'm pretty sure he didn't know the answer. He's like, good. And at the very end, what do we have?
3.
Who did that? Who said that? Cheater. All right, yes?
By following instructions, I cheated.
I'm just teasing. So we're gonna make this, right? We're gonna make this. All right. Make it bigger. All right. So some of the things we've already done. Okay. Same thing as before. We've added Redux in. We've enabled ES6 Babel. We're faking our import statement, and we've kind of created this view library. Let's call it, right? So let's take a look. Here's that. This looks familiar. So let's take a look at our view library, right? It's a function that accepts tally, on add, on subtract, on multiply, on divide. Okay? So it looks like it takes based on the number and then a bunch of functions, right? And then what it's going to do, it's going to figure out what the value is by trying to find this thing in the DOM and getting its value, right? Which we assume is going to be an input equals text, right? And then we're going to create this HTML, and it's called, show me the tally, provide, then show me the input form, add a bunch of buttons so we can do things, right? And then we're gonna just take that and we're gonna add that to our main page. Okay? We good? So in here we're looking. We've also already preloaded this thing on click, right? So we're going to say, hey, we're going to try to find the add button. When someone clicks on that add button, we're going to call this function that was passed in, this on add, right? And we're going to call that with the value of the input box. Pretty good? The same thing with subtract, same thing with multiply and divide, right? All we're saying is, hey, here, we're just attaching, once these things have been added to the DOM, we're going to attach event listeners to these buttons. And when they're clicked on, we're going to execute whatever functions you provided me with the value of our input box. So it doesn't know what those functions are. It's just going to assume, yeah, you're passing in functions. You know what you're doing. When you click this button, I'll call them with the current value in the input box. Yes? Good? All right, so task 1, we want to create a road trip dad reducer. Okay. And it needs to accept all these things. And then is anyone actually following along? Do you want me to put this in Slack or no? No? Okay. So it accepts the default state, right? We're going to say state equals 0. It accepts a type and a number, right? Looks like what our reducer needs to accept. Okay. We're going to switch the type. Let's just do the default first. Is return state. Okay, good. So case start. We want to return what? Case add. Return state plus number. And I'm just going to be lazy. We good so far? Feels kind of I know, right? So this is a little contrived, obviously, right? You can do this way more efficiently, but just demonstrating the functionality. All right. Where did our default go? There. All right, any questions about that? That makes sense to everyone? This is a contractual API, right? So.
No, I mean, if your state is 0 and you divide by 0.
Right. So it's contractual in the fact that we're assuming you know you've written this, you know what you're doing. So we could add checking if we wanted to, but we're opting here for it to be a contractual API. So next is we want to create those action creators, right? So we need a const add number, and it returns type equals add and a number, right? We're just going to do that 4 times.
think it's,
Did I mess something up?
is it an on add, on subtract, on?
It will be when we pass it into our app, when we hook it up. But right now, this is just the reducer part. This is just state management.
Why not the start state?
What's that?
Why not the start state?
Oh, yep, thank you.
Your types,
Did I do something wrong?
go down, so your type has add.
Yeah.
Okay, who do I address that?
Thanks. Subtract. How am I doing on time? All right. I think we're good here. Let's hope.
Semicolons?
Yes, if you're that kind, which I am. I am. All right, so we want to create the store, right? Same thing as before. Const store equals create store with our reducer, which is called road trip dad. Right? So now we have this store.
So create store can take an array of those?
You'll see. There's it's another thing you import from Redux. I'll show you. So we want to do this, and we want to call remember our app? We have the render. So we want to hook, now we want to hook this up, right? So we want to go store.subscribe. We're just going to do, let's look at the API for our app here. Our app needs this, right? And it's called, what's it called, render or app? Sorry, I don't remember. Render. And the first argument is store.getState, right? Because that's going to be a number. We just want the tally. So we want on add. We want that to be a function. So based on the API here, right? On the API here, it looks like this on add is being called in this way, right? It's going to be, it needs a number to be called in.
Can't you just use add directly there? Because it's already a function that takes a number.
Could, but then all it's going to do at that point in time is produce the object, right? We got it.
I thought add is your action creator.
It is. It creates the action object.
I see.
We need to dispatch it into the store.
Yeah.
So a lot of this is boilercode plate that you avoid when you don't create your own view library. Just over there. Okay. So we need to accept a number, and on that we need to store.dispatch number, right? That's the on add.
No.
Dispatch. I'm sorry. What was it? Add. We're good there. And then let's see. What did this thing? Dun, dun, dun. We don't ever have a start, apparently. Oh, yeah, we dispatch it down below. No, I remember. Okay. So add, subtract. Again, this is boilerplate. You
Got an extra S and subtract.
subtract. Multiply. So now we want to store dot. Let's
You
say,
may want to get rid of that line with number on it.
yeah, it's probably true, huh? And then I'm gonna just clean. Thank you, Aaron.
That's me, this JS
Store dot dispatch. Start. Pick a number. 5, 44, 5,
42.
10, 42. Okay. So over here on the right, you see we've had this thing already calculating, ready to go. So we can add 10. Subtract 12. Right, divide by 4. Right? Make sense? So again, a lot of that boilerplate code is because the fact that we invented our own view library. So using the ones that fit nicely in this picture actually do all these bindings for you. Nice and easy. So questions, comments about that?
Two light codings in one thing.
Oh, I'm not done. All right.
Jared?
Yeah.
Little off topic, but I've heard you can do time travel. Are you can get to that at all?
So so Redux has this idea of time travel, that because you're producing a new state every time, you can replay history, undo and redo really, really easily. You can go back and forth. You can debug easily if you've logged out and captured all the actions going on through your entire app, right? You can take that and replay them, and it's going to basically show you all the things that happened as your user was interacting with things, all the actions that are dispatching. You're going to see basically all those things that I just did. You can reproduce that if you've logged out those actions. That would include updating the UI and everything. So
Redux doesn't handle storing those actions for you. You have to.
So I think there's I think it's a middleware that lets you do that. Jason, do you use that?
It is, I do. There's it's gone from being a middleware to being a Chrome extension.
Okay.
And so you just basically, just click on the extension and then it'll pop up a pop-up. And every time your state changes, it rolls through and you can see it, and then you can click back or go back to that state whenever you want to. It's super slick and easy to integrate and easy to use.
Do you remember what it's called?
It's called Redux Dev. And anytime you're connected to a Redux app, then it kind of it changes color up on your toolbar. The cool thing about this dev tools also, not to derail what we're doing here, but you can also push these dev tools into production, and it doesn't affect your app a whole lot. And so you can, if you're having an issue in production, even though you have your code minified and whatever, you can still connect to it. You can watch what's going on with the state, and you can debug or do whatever you want to do.
So it's just back having that, the transparency into your state, and not only that, replaying it as it's mutated over time, right? So this is going to answer your question. Okay. And I'm running short on time, so this question was: essentially is the entire app state contained in one reducer, right? Because how would that feel writing that reducer? All right, no. So Redux shines at scale. So all that things that I did now for that simple add and subtract, right? That looked like a lot of code for what it was doing. But at scale, this is where Redux really, really shines. Its complexity is exactly the same, and it's very transparent. You can see what's going on, right? So Redux has this thing called combine reducers. So you import, create, store, combine reducers from Redux. You import all the reducers that you potentially would want in your app, right? You're going to create your root reducer, or just kind of you combine them all to create one big giant tree. And you do that with the combine reducers, right? You're passing this in. And then you create your store from that root reducer, right? And then, for instance, if I were to take that and ask to get state, what I'm going to get now is my state broken out as a tree. Here's what my talks looks like. Here's what my speakers look like. Here's what my sessions look like, right? In that particular case. Does that make sense, Jaime?
So you get n states.
You get the state of all the trees.
Still one state.
It's still one tree at the end, but you're basically saying, hey, pick all these things, compose them together, hook them up to one tree.
It's the state of states.
It's basically constructing a tree on the fly. I mean, you could shape this to be whatever structure. Like you can use that nested if you wanted to. But essentially you're saying, hey, I'm going to grab all these reducers and I'm going to make a completely flat structure like this. Or I could even, if I wanted to, I could branch it out. Flat's better typically, but.
So if you have two things that are affecting the same area of the state,
They probably belong together. You would import that reducer together.
right? So assuming somebody screwed it up somewhere, is there some sort of evaluation order that is applied?
So every reducer gets every action. So that was the whole reason why on the default, I don't recognize this action coming in. I'm just going to give you what you passed in. So everything gets every action.
So what state do the reducers get? Do they get the
They get the
persistent
current, what's in the current state tree.
state? And they all operate in parallel, roughly.
Yeah, so it just goes through and essentially produces, they all go through, it outputs a tree. Yeah, so you don't do, whether they do or not wouldn't make a difference in this particular
I
case.
don't believe it's parallel.
Yeah.
It's not,
There's an
it's-
order
it's
to it.
It is synchronous.
But yeah, it's a synchronous
It's
order
not
thing.
asynchronous.
That's
But
why you have unique.
Not
actions.
speaking temporally of synchronous or asynchronous, but they don't. The output of one doesn't go into the other.
Correct.
Yeah.
They're meant, you conceptualize your reducers as it being the only thing that exists in this app.
They have to be independent of each other if you think about how they happen here. So what happens when we dispatch an action, that action is going to get dispatched to each of these reducers with the state associated with that reducer. And it's going to say, based on that action, here's a new state, which combined reducers is going to say, okay, I got a new state for that thing, let me plug it into the combined state and send it to the combined
So the
state.
state associated with that reducer.
So you create a reducer, the reducer accepts a state and an action. And when you create your reducer, you say, hey, here's my default state or my initial state, right? Usually as you're using the default argument values, right? And so that's what your state tree is going to start as, right? And then from there, every time something gets dispatched in, Redux takes the current tree, whatever its state is, it passes that in and calculates that.
So the very first time a reducer is called, no state gets passed in, the default value is used, Redux gets that out, it saves it, and next time that reducer gets called, it passes that back in.
Correct.
Okay, got it.
Correct. And then you can actually, when you create your store, just to make this more confusing for you, when you create your store, you can actually inject in the default, which you would do, for instance, in an isomorphic environment. You determine what the state is on the server. You pass that down to the client. Then you say, when you create the store on the client, you actually say, here's the default state to start with. That was basically figured out on the server for you.
Which gives you a great opportunity when it comes to fixing a bug. So say that you log your state at a point that your app breaks, you can take that state and drop it into your initial state, and so your user can have the app running, whatever, and you can replicate the exact position where your app is at when it breaks to be able to debug from that point.
What if you need the state to cross pages?
The store keeps it.
Yeah, when you subscribe to it, you have one state. You determine which parts of the state go to which part of your component tree, right? So if you think of your front end as being just a bunch of component trees, you're going to say, hey, on this component tree, I'm going to divert this part of my state there. I'm going to divert this part of my state to this next tree. So basically, when you've created that binding, when you do the store.subscribe, store.getState, from there is where you're saying, hey, divert the branches this way. Does that make sense?
I'm just wondering how you would pull the state out of the store on one page to be passed to a different.
So this idea is a single page app, right? So It's one page. You're just navigating, you're just switching what you're viewing. So if you actually do a hard refresh, you're going to reconstruct your store, which isn't a big deal, but you're missing the benefit of a single page app, right? So let's visualize this. Maybe, Matt.
So when inserting a state, do you have to do anything special to connect a producer to the particular state that it cares about? Or does it take care of?
Say that again.
When you insert a state with an isomorphic app, you're inserting.
So when you're constructing the initial state.
Right.
Mm-hmm.
Do you have to do anything special to connect
No.
a particular piece of state to
You're basically saying the first time that an action comes in, instead of Redux calling all of its reducers with nothing, it's calling it with the thing that you passed in.
But that thing you passed in has to be constructed
It,
in the same.
yeah, it should be compatible. So the whole point of isomorphic is you actually have your same reducers client side and server side. So these are going to be compatible structures, right? But if they weren't, it would just work, and it would work as if I'm reconstructing my state from nothing.
So when you initialize your store with default states,
What's that?
when you initialize your store with default states, and you're using combined reducers, all of the reducers get that initial state.
Correct. Here, let me visualize this real quick, okay? All right, so here's your internal state tree. Here's the thing with two reducers, we've combined them, right? We have a type coming in, very similar, right? So what happens here is, because you use combined reducers, Redux knows which parts of the tree to pass to which reducers, right? So we've actually broken apart the tree, and we've given it one this branch and one the other branch, right? We're passing in the types. So then this reducer gets this branch of the tree and the action. The other reducer is getting the other branch of the tree and the action. That comes out and is combined to producing a new tree. Does that help? What?
I want to know how it knows how to break it apart.
Smart, I don't know.
That
It's open source.
keys of the-
It uses the keys of the reducer names. So like if you go back a couple slides real quick, you have one that's called talks. Okay, so the object in your state, when you access it from your view, will be talks and speakers and sessions. So it knows from that key name what's the state that's being passed into the reducer with the type, and then it returns an object that's named talks that attaches to the root state object.
It's a little less obvious because we're using ES6 here, that talks ends up being an object. So talk speaker sessions there ends up being an object with a key talks.
Correct.
That refers to a function talks.
Correct.
And a key speakers that refers to a function speakers, and a key sessions that refers to a function sessions. So the keys in the combined state for the combined reducers are talk speakers and sessions.
Correct. And then when you call it out, the things coming out match that exact same thing.
And
So it'd be like store.getState.talks and .speakers and .sessions at that point right there.
That's the data coming out, but the reducers would look the same coming in to create, when you're passing that into combine, create store.
and each reducer gets each action with each piece of the tree.
Every reducer gets every action that's always dispatched in your app no matter what. Okay?
But only its piece of the state.
But only its piece of the state tree.
And how do you know which reducers link to which piece of state because of naming convention?
Because of how when you do the combined reducers, that's what that does.
Can we get back to that second?
Yep.
Sorry.
Isn't part of that taken care of by the subscribe? Because you're not subscribing to the whole tree.
You subscribe, when you subscribe, it just tells you that I've updated or an action's coming in. Then you get the state, and then you say, hey, I'm getting the whole state, but what I only care about here, I only care about talks. So I'm going to pass talks on, right, to this part of the app.
So when I'm initializing my store from the server, I better send it an object that looks like that output down.
Yes, if you want to take full advantage of the isomorphic nature, yes. If you don't, it's gonna reconstruct it. It's not gonna break. You're missing out on the whole perk of being able to do that on the server.
So if I have something in there that's called hymns,
Called what? I'm sorry.
if I have something in there that's called hymns, there's going to be no reducer that will handle that state.
Correct.
Because I don't have a hymns reducer.
Correct.
Or if I had a hymns reducer but I didn't pass it in, it would get whatever the default was.
Correct.
And it would come out.
Yeah.
as hymns.
So I'm out of time, so I'm gonna go really, really fast here. Done that. So async behavior, to answer your question, right? Things you should never do inside a reducer, API calls, we talked about that, because doing so makes them non-deterministic, unpredictable, and opaque, right? So where is this managed? So I'm not going to do the live coding, I'm going to do the answer. Okay. Okay. So this is not the way you would, this is telling you how the behavior would look, right? But essentially what we want to be able to do, let's see. You know, I don't have enough time to do this.
Have you mentioned the egghead IO stuff?
Yes.
So I know, just a real quick blurb about this is that what Jared's going over, it seems super complicated because he really just doesn't have the time to cover what he needs to cover. And I can say from experience, and we're using this in our app currently, is that if you take the time to actually look at Redux, it actually simplifies what you're currently doing. It is an easier mental model to be able to think about your app and be able to work with your app, be able to divide up the pieces so your front-end developers can work on these different pieces of the app. And Jared's done a great job, but it's just a complicated talk to go over in 50 minutes. Yeah. But if you take the time, if you look at the egghead IO stuff, he goes into in-depth into each piece of this. And if you implement this into your current workflow, it will simplify your life, in my opinion.
Yeah. So I'll post this in there if you want to inspect what it does. But really the next thing is this idea of middleware. And you can add middleware as an extension between it being dispatched and before it gets to your reducers, right? So if it's visualized, it looks like this. You have a type coming in, or potentially maybe a function coming in. It goes through your middleware. A type comes out. That hits your reducers, right? So your reducers are authored the exact same way, and that produces a new tree, okay? That's the cleanest way to implement asynchronous behavior. And so that means you write your reducers exactly the same way as synchronous, right? It's still clear, easy to do, but you just intercept the actions coming in beforehand, right? And those you know, you can still send in just regular objects, but now you can send in other things depending on what middleware you've added, right? And that would include thunks, which is basically a function that is already pre-bound with some stuff that maybe would kick off some asynchronous action, and then when it's done, it's going to actually then inject in the object, right? And so, you know, there's a library called Redux thunks. It's one I like particularly. It basically, this is applying middleware when you've created it here, okay? You're creating the store, you're applying some middleware. Again, this is completely optional, but this is just, it's a nice little to-have, right? And then what you do is that you author action creators that return more than objects. They can return functions that, when called, returned objects. Okay, that's a little more complex, but that's the cleanest way to handle asynchronous behavior. But you don't have to do that. There is a way around it, and that's in that code pin that I'll put out on the front end channel if you want to look through it. So sorry, I ran out of time, big time. Any questions or comments? No. All right, I'm done.